All right, Chem Scholars, we're back at it here. Going to review empirical formulas, get into the idea of molecular formulas. So, number 18 is our do now. A compound is found to be composed of 20.19% magnesium, 26.64% sulfur, 53.7%, 17% oxygen. What is its empirical formula? All right, pause the video. Bam. Okay, give it a try. But there it is. Okay, so you notice I took the percents, assumed 100 grams, so 20.19% would be 20.19 grams, 26.64 grams, 53.17 grams, divided by the molar mass. Magnesium's is 24.3, sulfur's is around 32.1, oxygen's is about 16.0. That gives me my moles. So I had 0.831 moles of magnesium, 0.830 moles of sulfur, 3.32 moles of oxygen. I kind of skipped where I said I divided by the smaller number. So I divided each by, technically I guess that's the smaller number, 0.830. And okay. Okay, so obviously 0.831 divided by 0.830 is close enough to 1. 0.830 divided by 0.830 is 1. 3.32 divided by 0.830 gives me a pretty close to 4. So we have MgSO4. But that may not be what you think it is, and you might not even know what it is. But again, that's the empirical formula. So now we have to talk about molecular formulas. But before that I do that, let me review again the difference between empirical and molecular. So these are actual formulas. These are molecular formulas, although this one is a pretend because there is no element X. Okay. Now, if I asked you to find the empirical formula, what would you do? Right. Exactly. Yep. You're right. Good. No argument. Okay. We have to simplify. So a 6:6 ratio would mean C to H. Okay. And 8 to 18, I can't divide them by 4, can't divide them by 3, but it can divide by 2. Okay. So we would have a C4H9 empirical formula. All right, 1 and 2. Well, there's really no way to simplify that, so it's still just 1 and 2. Okay, an empirical formula and a molecular formula can be the same thing. They just don't have to be. All right, 2 to 6 to 2. Only numbers I could divide through there is 2, so that gives me 1 to 3 to 1. And in this weird case, okay, they're both divisible by 13, so I would have x, 3, 5 as the empirical formula. All right, I wanted to show you that because in order to go from molecular to empirical, you had to divide by some common multiple, okay? Well, when we reverse that, means that we're trying to figure out what that multiple is to go the other way, okay? And so we need one other piece of information. We found empirical formulas, okay, but that alone doesn't get us there, okay? We need the molar mass of the compound, okay? So if we have the empirical formula and the molar mass, like we do in number 20 here, then we could actually get this done. All right, so here's how. The first thing we're going to do is figure out what the molar mass of this is. I call it the empirical mass. So I'm going to actually add up 2 carbons plus 1 oxygen plus 4 hydrogens. Okay, carbons are 12. Oxygens are 16. And hydrogens are, not dollar signs. Hydrogens are 1. 24 and 16 is 40, and 4 more gives me 44 grams per mole. So my empirical mass is 44, but the actual is 132. So what we're going to do is divide the actual by the empirical to find our ratio. And so 132 divided by 44 gives me a number 3. And again, at this point, you really have to have a whole number. If you can't get 2.5 or anything like that here. It's got to be pretty darn close to a whole number. So that means we're off by a factor of 3. So our formula has to go up by a factor of 3. So that means our molecular formula would be 3 times 2, or 6 carbons, 3 times 1, or 3 hydrogens, 3 times 4, or 12 hydrogens. So that is our molecular formula, or what I like to call our MOFO. All right. So it's really simple. If you have the empirical formula, we just add it up and divide the actual by the empirical molar mass. All right. I'm going to go through one more with you, then you're going to try the next couple. So I'm going to break this down. I'm going to say that we have 4 carbons, 4 hydrogens, and 1 oxygen. Kind of similar to the last scenario. All right, so we have 4 carbons plus 4 hydrogens plus 1 oxygen. 16 and 4 is 20. And 4 times 12 is 48. So that gives us a total of 68 grams per mole in this case. All right, so I'm going to take my actual, divide by my empirical. The actual has to be given unless you're doing a lab, in which case you would find it, but we're not doing that right now. So 272 divided by 68 sounds very 4-ish to me. Okay, so that means now I have to multiply my formula by a factor of 4. Okay, so let me give myself a little typing and go 4 times 4 is 16, 4 times 4 is 16, and 4 times 1 is 4. So that is our MOFO. Alright, pause the video, give 22 and 23 a try. But I'm going on. Alright, so CH2, that's 1 carbon and 2 hydrogens, which is 12, plus 2 times 1, so that's 14. We're going to take our actual, 84, divide by our empirical, 14, right? 84 divided by 14. I'm getting a little tired of typing here, sorry. So that's what, 6? So our ratio is off by a factor of 6. So it's really C6H12. All right, one more. We have a little bit longer one, C2H4NO. So we have 2 carbons, 4 hydrogens, a nitrogen, and oxygen. Carbons are still 12, hydrogens are still 1, nitrogens are 14, and the oxygens are 16. So 14 and 16 is 30, 34, and 24 is 58. And okay, so our actual is given as 116.1. I divide that by 58. I'm not going to get exactly 2, but I'm going to get real close to exactly 2. So our formula is off by a factor of 2. So I'm going to have to take this formula and double it. So 2 doubled is 4, 4 doubled is 8, 1 doubled is 2, and 1 doubled is 2. So that is dimethylglyoxime. Woohoo! Alright. So let's put it all together. So here is a problem where we're told the compound is 36.8% nitrogen, and we know the rest of it is oxygen. Okay, we want to find the empirical formula, and then we want to find the molecular formula. All right, and then we want to name the compound. Oh no, name nomenclature too. Ah, all right. So give it a try. Pause the video, and I'm gonna put it up there in a second. All right. If you're going on, I assume you're done. Bam. Okay. So we had 36.84%. of nitrogen. So that meant the remaining 63.16% had to be the oxygen. So I probably should have labeled this N and O. I prefer to label things. Okay, the molar mass of nitrogen is 14 grams per mole. Molar mass of oxygen is 16 grams per mole. So we get around 2.631 moles of nitrogen, 3.948 moles of oxygen. When I divide it out, I got a 1 to 1.5 ratio. All right, I knew when I see those halves, I have to double. So that means my empirical ratio is 2 to 3. And so my empirical formula was N2O3. But we want now go on to molecular formula. So I take that N2O3 and I add it up. Okay, and I had, let me, I guess, spell it out. I shouldn't cut steps. 2 nitrogens and 3 oxygens. So nitrogens are 14. I guess I'll write the decimal. Oxygens are 16. Okay, so 28 and 48 gives me 76. So now I take my actual molar mass, given as 228, divide by my empirical, which we found is 76. It means I'm off by a factor of 3, which means my molecular formula is N609. Okay, and now we can talk about the nomenclature. Now this is old nomenclature, right? This isn't about acids, and this is not, you know, one of those other things. Ionic compound. Why is this not coming out of? We'll just copy. All right, whatever. All right, so the name of this should be hexanitrogen non-oxide. I guess I should just bump it down. All right, so that's putting it all together. All right, one more, but I'm going to save this. This will be our do now for tomorrow. Have a good day. Bye. Oh, wait, look at the time. I only used 12 minutes. Ah, psych. We're going to talk a little bit more about this, I guess. Let's do this one. Yeah, let's do it. All right. So, pause the video, give it a try. I'll put up the answer in just a couple seconds. All right, if you're going on, I hope you actually tried it, and I hope that you found out it was K2C2O4. Okay, we had 47% potassium, which is kind of covered up by me, 14.5% carbon, 38.5%, so I made those grams. I divide by the molar mass of the elements, and then I simplified by dividing by the smaller number, so I took divide by 1.2. Yeah, this one was a little rough, you know, sometimes there's a little bit more round off. It's all good. So we had a 1 to 1 to 2 ratio, meaning that our empirical formula is KCO2. I add up 1 potassium, 1 carbon, 2 oxygens, I got about 83. 166 divided by 83 is 2. And so our MOFO was K2C2O4. And that is something you should be able to name. Okay, you should know that that is called potassium oxalate. Okay, wasn't asked there. I just did it anyway. All right, now that we've done that, now I'm going to stop this because I don't want to get into this last section now. Okay, so use any extra time and go get that homework going. All right, because we only have one more section of this. Ciao.